Welcome to solverfy.
Okay, we have a statement. Sodium is larger than sodium cation. Is this true? Well, let's explore. I think one way that we can look at this is to look at the valence shell of sodium as compared to sodium plus. Now recall that in the periodic table, sodium is in group 1, right? So there's hydrogen, lithium, and then sodium. Okay. As such, we should expect that sodium, neutral sodium, will have a single electron in its valence shell. So the picture we would have of sodium, neutral sodium, is sodium with one electron. Okay, now the question is, what does sodium plus look like? Well, if we take sodium with one electron and strip that electron away, we get sodium plus. And then we'd have an extra electron floating around. Okay, well, what does that tell us about the size of sodium and sodium plus? Well, we can think of sodium plus as being like sodium, but with one less electron. Now, recall what controls the size of atoms. We have the nucleus, which is very, very tiny, very, very, very tiny comparatively. Okay. And then the electrons, the electron cloud, is what defines the actual shape of the atom. And it just so happens that in terms of relative size, the size of the protons, or the nucleus rather, is basically insignificant as compared to the electron. I've once heard that it's similar to, say, if the uh, nucleus is a tennis ball, then the electron cloud is like a soccer stadium around that tennis ball, right? So electrons are synonymous with size. Okay, well, by that nature, we can kind of intuitively grasp that losing an electron would shrink the size because there's one less electron in this cloud, this outer cloud. And then one other thing is that remember that electrons, we have in a neutral molecule one electron for every proton, right? And so in the end, they're neutral. Well, in the case of sodium plus cations, since we've lost one electron, we actually have an additional positive charge, one more positive charge than we do have electrons. And so those electrons are actually being pulled more strongly by sodium than they normally would because it's more charged than it normally would be, right? And so for that reason, not only is there just one less electron, the electrons that are there are being pulled more strongly towards the center or towards the nucleus. And so we do indeed find that, yes, sodium is larger than sodium plus. In fact, any atom which has additional electrons added onto it will be larger than the same without the additional electrons. And anytime you strip electrons away from an atom, it gets smaller.